You should start the recording right about now.
You rock. All right, recording has started. Thank you very much, Rod. Go ahead, and then I'll go after Rod. So.
All right, good afternoon, and thanks for coming again today. It seems like things are somehow leveling, and we're starting to hear about hybrid events. We probably are not going to do anything in person yet. Maybe we will look at the last part of the year and see how things go. If we don't get a twindemic or a something worse, and see how things are going. It seems like for the most part, most of us that have either managed to stay employed and do okay, or soon we'll get another job. The ones that lost jobs had, for the most part, been finding jobs too. There are jobs. If you need help, please go on the jobs channel. Ping some of us. There might be positions that are not advertised, or we might be able to push you in or help you. Today we're going to have two presenters that I know very well. One of them is Phil Berlow. He's going to talk about GNU radio. And then we have Tony, which is an old schooler. I work with Tony already. We work with Tony at JASC, and Tony is an awesome researcher, and he's very passionate about threat intelligence, and he's going to talk to us about MISP. And I suggest you to pay a lot of attention, because you can use this, and you can use it for your own investigations. Before we get started, again, I'll thank you. If you have any feedback, I read somewhere in the Slack that somehow Discord killed our channel. That's very sad to read. In all honesty, I don't know what to do about it. I don't know if we should go back or what, or we were using a bot, and the bot seems to be patching up things a little bit, but I do feel like the momentum has decreased with the adoption of Discord. You know, we had all these expectations about Discord, and it turned out to be an absolute disaster. So there's something that I'm gonna put this out there for you guys to try to figure out how well we do. Should we go back to Slack and stick to it, or because I feel like in between both, we're losing communication. I myself, sometimes I log in and I'm like, oh my God, I lost this huge thread that was incredibly interesting. I could have got some of it. I could have collaborated with it. So I'm a little concerned about the whole Discord thing. I know the kids like it, and they all do their DJ and their stuff, and that's pretty cool, but it seems like the majority of the people are not getting it. I'm sorry, and I include myself in that group, but I'm somewhat lost in this Discord thing. And after DEF CON, in all honesty, I got a pretty bad flavor out of it. DEF CON had to do support sessions, and it was not good. It was convoluted, and I don't mind using it and keeping it as a backup, but I feel like we don't have what we used to have. That's my perception as of today. I'm not sure if you guys agree with me or not, but definitely, I'm not the only one. Like, there's been people posting and saying, hey, yeah, this is sort of lost momentum. So I'm gonna put this out there. We are gonna continue meeting online until we make a decision. The next big event, which I will let Danielle announce it, is the South Florida ISSA, and she will give you the details. We also have PISA's Orlando at one point, which is our friends in Orlando, which usually put up a great conference. Other than that, I'll keep participating, come up with ideas so we can fix this Discord Slack thing, and I'll leave you guys with Danielle.
So thank you, everyone. Now that he has told you all about Discord, so we're going to circle back to that in a second. So South Florida ISSA chili cook-off, hack the flag, which would normally be, but we can't really figure out a way to do the chili cook-off. So you're certainly welcome to make your chili at home, make 2 batches, enlist your spouse, enlist your kids, you know, battle it out amongst each other. That's fine. However, more importantly, we will be holding the conference in a hybrid situation, a different hybrid than what Rod's talking about. But we're actually going to have the lobbies and everything in Discord now that Rod has hyped all that up and gotten everybody excited about Discord. So Discord Discord will be the common meeting place for chatting, finding your teams and everything. We are not going to be, I don't like to set myself up for failure. I set myself up for success. So we're not actually going to be presenting the sessions via Discord. It will just be the place for everybody to mill and talk. I will be doing my thing. I will be using Zoom to present the talk, so we're not going to have those issues. I will handle that. We will also have the CTFs. There's going to be a beginner CTF, an advanced CTF, and our very own Rod is in charge of the advanced, obviously. So we'll have some fun working on that. Like I said, everybody will mill around inside Discord. You can find your teams there. We're going to create team channels so everyone can, get together and talk and share your clues and experiences and everything. So it'll be similar to what we did in person, where everybody sat at the table. However, what I need is help. So I'm in charge of this Discord thing, and Rod just told you how difficult it is. I need help. So I need help with information booth goons, basically. You will be my evil minions. So I need people to say, this is where we're going. This is how you get to the CTF. This is, the room you need to be in. Go check the links over here. Just helping me out, corral the people. So I would be ever so thankful if I got some volunteers. Phil even offered to help me in the morning. He is going to join the CTF in the afternoon, but he's going to help me out in the morning as well. I really can use the help. However, if you choose to volunteer and help me, if you do it in the afternoon, love to have the help, but you probably won't be able to participate in the CTF. So choose wisely, red pill, blue pill, up to you. But I need all the pills and I need all the help I can get. So DM me, everybody knows where to find me, Miss Gizmo. Find me in Discord, find me in Slack. I don't care where you call me, just volunteer and help me out here, guys. So it will be October 3rd. I will put the South Florida ISSA conference link in and the meetup in the chat today. And without further ado, now that I've begged and pleaded and had your unbent ear, I appreciate it. I will offer up Phil as our first speaker, and he is going to be talking about the radio, the GNU radio, and various other things in here. I saw a little bit of his presentation earlier, so I will let him set it up. I will let him introduce himself because he can do it even better. Thank you very much, Rod. I know you have to drop off, but thank you for coming. And I need you 15 minutes soon, okay? All right, thanks. Have a good day. Everybody have a great conference. I am recording. Phil, it's up. You're up. Go ahead and share your screen, and Tony will be up next.
All right, Danielle, thank you very much. Let me go ahead and share my screen and pull up the presentation. So this is an introduction to GNU Radio. For those of you who were at my last presentation on software-defined radio, this is basically a direct sequel to that, a follow-up to what was covered there. There is a lot of overlap with that. In fact, I just straight up stole a bunch of the slides from my last one. So hopefully we'll be reviewing some of the concepts. So who am I? My name is Philip Borlow. I am a senior security engineer at Vigilant Security. I'm also a licensed technician class ham operator since 2018. But really my only real qualification for this is that I'm a hobbyist. Been interested in radio, Wi-Fi, Bluetooth, software-defined radio in general for about 10, 15 years now. Given a few talks here at Hackmiami related to radio. As I said, one on SDR, a few others on Bluetooth. But really, I'm not an expert in this field, and this talk is really just to give you a sample of SDR, radio, and these concepts from a hobbyist perspective. So a little agenda for what we're going to be talking about today. I'm going to be starting off by talking about some just basic radio concepts to give us some foundation. Then be going into some digital signal processing and software-defined radio concepts. Again, just the basics, just the foundation level stuff. And then talk about the foundational aspects of GNU Radio and where that fits into the picture. And then in the last about 15 minutes, I'm going to transition to a demo and cover all of the concepts that we covered up to there and show you a demonstration of what it looks like in GNU Radio to see like an AM radio, an FM radio, or even to demodulate digital signals like on-off keying. Important note though is there's a lot of stuff I'm not going to be covering today. Software-defined radio and digital signal processing is a pretty deep field. You know, you have to have a background in electrical engineering to really understand a lot of these concepts deep. So I'm going to be skipping over a ton of stuff. I would recommend, though, that you guys kind of follow up. A lot of this talk is based on this 3-volume series, Field Expedient SDR. All of the examples I'm giving today are pulled exactly from their site, fieldxp.com. It's free. You don't have to buy the book to get the examples. So if anything I show here interests you, I recommend you go on there and download the samples and just play around with it. And the second thing is Michael Osman, the creator of the Hack RF, put out a great 11-part video series, again, free at their site, that walks through basically everything we're going to be covering here today in GNU Radio. So I recommend you guys go check that out. So let's start with the real basics. And I assume a lot of you guys, I'll show you guys the book titles at the end, but basically just to answer a question in chat, it's an introduction to software-defined radio, field expedient SDR. It's a 3-volume series. You can find it on Amazon, and I will be linking to it after the talk. So some radio basics. You know, the basic ideas of a sine wave. You have your amplitude. When that comes to sound, that's how loud you're speaking. You can see that here, the amplitude is shown by the y-axis. You have your frequency, right? The shorter the period, the higher the frequency. These are some pretty basic concepts. And then one that might be familiar to some of you is phase. And so 2 different waves of the same frequency and amplitude can have a different phase, and that just means that basically they're different places in the wave. So if you were to take these 2 lines as being like second markers, the red wave would be at a value of 0 at 3 seconds, where the blue wave would be at a value of 0 at 4 seconds, right? So it's just where upon that wave that is. And these are the basic aspects of a wave that we'll see. Another really important concept here is called the Fourier transform. And this is really a foundational concept to digital signal processing and signals in general. And it's the idea that any complex waveform that you have, like up here, this might be an audio waveform or radio signal. It looks complicated, but you can break that down into a series of simple waveforms. And this is a really important concept in radio. This chart down here at the bottom left is what we call an FFT plot, a fast Fourier transform plot. And instead of showing, you know, the amplitude over time, what it shows us is the amplitude versus frequency. And this allows us to see which frequencies are the largest component of this complex wave. And so to read this chart, we would see these 2 big spikes indicate that those 2 frequencies make up the largest portion of this wave. But we also see, you know, there are a bunch of other frequencies all throughout here that make it up. And this is just a fundamental concept of signal processing. The last thing here is I want to show you is a waterfall graph. So whereas this shows us amplitude over time, this graph shows us amplitude over frequency, the waterfall kind of gives us the best of both worlds. So we can see the intensity shows us the amplitude, the frequency is shown by the x-axis, and the y-axis is time. So we kind of see all 3 of them at once. And these are just 3 different ways that we can visualize waves, and they'll come up throughout the rest of the talk. So let's talk about a few radio components and components we're going to be seeing coming up. In basically any radio system you're going to see a mix of these components. So the first one is pretty straightforward. It's an amplifier. A lot of you are probably familiar with it. Doesn't change the frequency, doesn't change the phase. It simply just amplifies the amplitude of the wave. Pretty straightforward. Filters, you know, as the name implies, filters out frequencies. So if we imagine these images here are a Fourier transform, you can see these lines as being which frequencies would be allowed through. And that's just basic concept. So a low pass would allow any frequencies below a certain frequency through. High pass, the opposite, any frequencies above a certain frequency are allowed through. Band pass allows a certain frequency range allowed through, and a band reject or band stop rejects a certain range of frequencies. And then the third concept is a mixer. And this simply is a way of combining 2 signals. So this is the first place that I'm going to kind of brush over, but what I want you to get out of the mixer is you can combine 2 signals, and the output is either going to be it's used for 2 things. One is amplitude modulation, which we'll talk about in a second, and the other is for shifting frequencies. So you can have a frequency come in, put another frequency, and it will shift that frequency over. And that concept will also come up in a little bit. So let's actually talk about how this might come into use, how waves are used. Let's talk about a speaker and a microphone, right? So when you talk, you are producing vibrations in air pressure waves, and human hearing occurs at around 20 hertz to around 20 kilohertz. Middle C is around 261 hertz, right? So let's say you want to record that and play that into a speaker. You take a microphone, you sing middle C, that's going to vibrate a diaphragm back and forth that has a magnet on it next to a wire. And that's going to vibrate back at 261 hertz and cause an electrical impulse to go down that wire at 261 hertz, right? To play that back, you just play that into a speaker, which is an electromagnet and a magnet, and it's going to push that diaphragm at 261 hertz and cause the air to vibrate. Pretty straightforward. But let's say you want to play this over radio. Well, 261 hertz is extremely low for radio. That's the kind of frequencies that they communicate with like submarines with. You need an antenna that's miles long and, you know, extreme power draws. That's not going to work for us, right? So we need to encode the information that we have, the audio at around 261 hertz, onto another wave that's going to carry our information at a frequency that we can actually work with, right? So we're working at 261 hertz, but we're going to be using a frequency for AM, which is around 500 kilohertz to 1500 kilohertz or 1600 kilohertz, right? So how do we do that? Well, this brings back up our idea of a mixer, and you can see this little animation here. We have our carrier wave, this AM frequency, and we have our modulated signal. This is our audio signal, and we're putting in through a mixer, and you see it doesn't actually change the frequency, at least in this AM modulation, it doesn't change the frequency of our carrier. It changes the amplitude. And so we can see there are multiple ways of encoding information here, and this is just the basic idea of modulation, of how we can take a carrier wave and take information and put it on top. And this works not just for analog signals, but we see how down here, it works for digital signals too. And so let's actually talk about a few different ways that you can encode information on waves. All right, so we talked about amplitude modulation. You know, you can have your carrier, you have your input, and it comes out varying the amplitude. Well, we can do the same thing with frequency. We bring in the same input, same carrier, but now instead of changing the amplitude, we're changing the frequency of the wave, right? And then this also works, and this last picture just shows that this also works for digital signals. So let's actually go through these. We're familiar with AM, amplitude modulation. When you do this for a digital signal, this is called amplitude shift keying. And there are multiple forms of it. One that we'll see later in this presentation is called on-off keying, and it's just a very simple form of digital amplitude modulation. You're probably also familiar with FM radio. In terms of digital, that would be called frequency shift keying. MFSK is multiple frequency shift keying. You can use more than two frequencies. It doesn't just have to be binary. And this kind of brings up the idea that you can encode a lot more information if you use more steps. But it sometimes brings in an additional complexity or additional error rate. So there's balances there. And then the third one, which might be less obvious, is phase modulation. So the phase is the third attribute of the wave that we talked about, and you can use that to encode information. So phase modulation and phase shift keying. And then the fourth one, again, I am completely skipping over this. Quadratures, in phase and quadratures is kind of an artifact of digital signal processing, completely leaving it out. I touched on it a bit in my last talk. The only reason I'm bringing it up here is if you look into things like how Wi-Fi works and how modulated there, it tends to use quadrature type modulation. Just bringing it up in case you run into that. So we've talked about how we can encode information on waves, but we don't want to be stuck to one radio station. Radio is not great if it can only tune into one station. So you want to be able to tune it around and go to multiple stations. So how do we do that? Well, we can broadcast information on multiple different frequencies or channels in this case, probably familiar with that, and use filters to, you know, filter only the channel you want and filter and get rid of everything else. Great. The problem is that filters, making a filter that you can tune, that you can change which frequencies it work for, while possible, is really complicated, really expensive. It's not the way we want to do it. They figured out a long time ago that the way to do this is to make a fixed filter that works for a single frequency, a single range of frequencies, and then shift around the frequencies. We brought this up earlier. A mixer can actually change the frequency and shift it around. And so that's the way we're going to do this. We're going to use a local oscillator to shift the incoming frequency to meet the filter that we have. And this is a concept called heterodyne, and it's a concept here called super heterodyne receiver. And so when you tune that dial on your radio, what you're changing is not the filter, you're changing the waveform of a local oscillator that you're mixing into the incoming frequency that's going to move it around. Right now, this introduces a few kind of issues. One being an image. Again, this is one of these aspects I'm kind of brush right over, but it does introduce kind of like artifacts, like mirages, harmonics of the frequency that we have to be aware of, and it kind of produces some limitations of this in terms of how broad we can make these filters. But this is a basic concept that is basically at the foundation of all radios since the 30s. Right. So as I said, most of what we've covered is basic radio concepts that have been true since like the 30s. So what about software-defined radio? Well, it's the idea of radio where we implement some of the components we've been talking about, like mixers and amplifiers. We're doing some of that in software. Now I say some of that because the majority of it is still being done in hardware. I have a HackRF. I guess I don't have it around me right now, but we talk about like the first and second stage here are still being done in hardware. It's really only the modulation, the demodulation of the signal that's being done in software. Why is this important? In your car radio can really only do FM and AM, and those are two different components in that radio, but it can't decode TV signals. It can't decode, XM radio. Software-defined radio, as long as the antenna and the receivers are tuned for those frequencies, it can just change how it demodulates. So it's a lot more flexible. It does introduce some drawbacks, and the main one being it's limited by the sample rate. So let's actually get into that. What is sampling? This is this conversion from the analog to digital domain. Analog signals are continuous. It means they have a defined value at every point in time. Right? Digital, on the other hand, it's discrete. It exists as discrete ones and zeros, which means that the resolution is a factor here. The rate at which you sample the signal is going to determine the resolution of the signal. And we can see here up top an analog signal and its digital representation. These bars are, an estimation. Why is this important? Well, if you're sampling at a rate that doesn't match your signal, you're going to see a signal that isn't true. This top rate is based on these dots. This is, a pretty good guess at what this signal probably looked like. But the sample below is showing you that if you had a really fast signal that was much faster than your sampling rate, you're going to get a mirage. You're going to get this false signal. It looks like it's much larger, and it's just because it happened to coincide. If you've ever seen like a rolling shutter with propeller blades where you snap shots at different times, that's this effect. So it introduces this idea that you have to be cognizant of what's the frequency you're sampling and how fast are you sampling it. And it's going to introduce some artifacts. So that's software-defined radio. Let's talk about GNU Radio specifically. So GNU Radio is a software development toolkit for signal processing. It's written in Python and C, so it's basically a set of libraries that you can do a lot of what we're talking about, implementing, mixers and filters and amplifiers. You can do that in software, and it allows you to do that. It's cross-platform. But what I'm going to be showing you today is GNU Radio Companion, and that's a WYSIWYG interface that's built on top of it. So you don't have to, traditionally GNU Radio, you would be, programming in Python. This allows you to do everything completely without touching code, which is nice, especially it reduces the barrier to entry. I do want to make it clear though, for those getting into software-defined radio, you probably aren't going to want to touch GNU Radio. For most applications like receiving TV broadcasts, decoding images, speaking, AM, there are purpose-built applications. It's probably what you want to use. GNU Radio is like, the raw tools. So this is useful for if you're building new applications or if you're learning digital signal processing or reverse engineering a new signal. It will allow you to break it down every step along the way, visualize it, and kind of debug what's going on. I just want to tell you, most of you guys, if you want to get into, radio and SDR, you probably don't need to touch GNU Radio, or you'll find people save files who have already implemented it, who really understand digital signal processing, and you'll use it. But it's fun to be able to play around and see what's going on. And then the last point I'll put up here, and I'll just throw this out to save you guys some headache, don't run it on a VM. When we come to sample rates and frequencies, the latency introduced with a VM, it just causes all sorts of issues. So try and install it on bare hardware. I'll go over a few of the kind of basic components of GNU Radio here before we get into some of the demos. So the first few are variables and GNU and GUI entries. The idea being that throughout your entire schematic, you're going to have amplifiers and mixers that are set to certain frequencies or sample rates, and it's annoying to have to update those all over the place, right? So having variables in GNU GUI entry boxes allows you to just implement it once, reference it throughout your code, and just update it in one place. And it'll allow you to actually like implement tuners. Like when you make an AM radio, we can have just a slider to move what radio station we're tuned to. Sources, as the name suggests, is a source of information. This can be things like a file source. It can be, you know, a WAV file. It can be a hardware source, such as an SDR, or it can be like an array. I'll show you in the on-off keying section. We'll just have an array of zeros and ones that we feed into our flowchart. Sinks are the opposite. It's where we're putting our information. So just like we can read from a file, we can save to a file. When it comes to audio, like a AM radio, FM radio, we can put it out to an audio sync and put it out to our speakers. Or you know, any sorts of types of, the really important ones are the GUI syncs. These are visual outputs that allow us to see, we talked earlier about things like the fast Fourier transform plot that allows us to see the frequency over time. And it'll just be able to allow us to visualize what's going on. That's probably the most important tool in all of this. Radio components, as we talked about, mixers, amplifiers, filters, those are all implemented as components. Obviously, I'm not going to get too much into it. We can, you know, I'll show a few of them off in the demo. Type converters. This is an important idea in GNU Radio. There are different forms of information. They come in different formats, and you have to be cognizant of them as you're moving them around your system. Complex numbers, floats, integers, binary representations. They are all color-coded within GNU Radio, and you will be having to convert from one to another. And it just adds a little bit of complexity to some of these flowcharts. Sample rate related. Again, we were talking about how sample rate comes into digital signal processing. As you go throughout your flowchart, there are going to be a lot of components that either decimate or interpolate, either fill in data where there wasn't any, or throw away data where it's not necessary as you're transitioning from one sample rate to another. Again, another topic I'm going to be completely skipping over since I don't have the time. And then stuff like math. Some of the basic ones like multiplier, how you implement mixers. But you can do also sorts of mathematical functions in GNU Radio. That is the presentation portion. So with that, that should give us a foundation to actually start jumping into some demos. So this is GNU Radio Companion. This is, I modified a few of the examples that came out of this Field Expedient SDR book, and it'll walk you through most of these examples. And you can see here a few of what we were talking about. So we have things like a file source, and this is a source from the radio example. So I didn't have to hook it up to a radio. These are, you know, a capture of an AM broadcast. You have things like text boxes and variables to keep track of our sample rate and what frequency we want to tune to and what the center frequency of the filter is and stuff like that. And then we can actually see, you know, we talked about the heterodyne radio, and we have things like a mixer here and a low pass filter and an AM modulator. And what this allows us to do is we can see we have things like GUI syncs here that allow us to visualize these signals as it works its way through our system. So let's go ahead and actually boot this up. We'll go ahead and run it. And what will pop up is our signal. So let's go through this. Here's our AM input, right? Here's the signal that is coming out of our file. And here's what's coming out of our multiplier. They look very similar. And if you notice, look at this peak, it's been shifted over. Well, that's exactly what we were talking about our mixer was doing. We input a sine wave, a cosine wave in this case. What is that? 20 kilohertz cosine wave. And we're shifting this frequency over. So this is an example of what's going on in a super heterodyne receiver where we're shifting it over to from its, what is this? Running at around 900 kilohertz, right? A radio frequency, around 880. Here, though, it's around 0. This 0 is shifting it over for our filter. Our filter is built around 0, right? So this is one of the ways you can kind of visualize this as it's going through. So let's actually pull out and disable these outputs. Guys, I know you guys are answering a lot of questions. I will look at those at the end of the talk and cover all of them. So there's our output. Let's actually look as it goes from our multiply output to our filtered output after our low pass filter. All right, so let's run it again. Here's all our filters, and we can see all these spikes are likely other radio stations. They're on other channels. We've shifted this to 0, and as we see, we've now removed everything around it. So we've isolated just the AM station that we want to talk about, and that's what that low pass filter is doing. So we're able to very easily visualize what these components are doing. So let's keep going. Let's disable that guy, and let's enable the final output and a audio sync. And there we go. Look at that. So here's the radio station, the channel, and here's the actual audio waveform as it's coming out at the end. And so in a really quick way, we've demonstrated that super heterodyne receiver with an AM radio station and broken it down. And this shows how GNU radio can be used as a really good tool for showing what's going on at each step in the process. So now jumping over, let me show you a quick example of an FM broadcaster and receiver. So in our last example, I was showing pulling from a file, right? So someone received a file in probably a software-defined radio and threw it just directly into a file for processing later. And that's actually what SDR is great for, pulling from files and analyzing signals after the fact. But in this case, we're actually drawing from a WAV file. This is just an audio source. So we are going to be going through, broadcasting, and then receiving in the same diagram. So what comes out at the end, this is basically just a fancy way of playing a WAV file, but we're simulating it going through an FM broadcast. So this is a little bit more complicated. AM is much more straightforward to implement than FM. So I'm not going to go through what each one of these blocks does, but we can see here we have things like a transmitter. This X-Lighting FR filter is just a fancy way of doing shifting with a mixer and filtering all in one, which is just something that we do often. So let's actually, let me disable the audio. Oh, no, I can't disable the audio sync. It's going to yell at me.
When in the course of human events.
So we can see the audio.
When in the course of human.
Let me turn that down. So here, it's a similar implementation as we saw before. Now, in this case, we're using a different GUI implementation, and this allows us to switch how we visualize this. So instead of just a frequency display, we see, okay, this is at 98, what is that? Probably megahertz, okay. We can also see it as a waterfall display. And we start to see some of the issues that come up, like aliasing. These are filters that we need to now filter out. Right? So just interesting that we can see these different visualizations, and it allows us to just identify the type of modulation from a distance and what's going on very quickly. So I'm not going to spend too much time on an FM sample. I think what's a little bit more interesting is this. This is an implementation of an on-off keying. So our source here, instead of being a file, is literally just an array of ones and zeros that we want to transmit. And we are going to see what this looks like. So let's start it off. We see what our digital input is. It's a digital waveform, 11010101000, blah, blah, blah. Cool. Let's see what that looks like after we have, modulated it. So we go from a digital signal out to now this. Okay, so we're getting spikes at this one frequency. Let's change the visualization here. Okay, there's something over here. Let's change the contrast to make it a little bit more. Okay, we got something now. Let's zoom in. So there's our digital signal. On-off keying, it's turning on and off at this one frequency, right? So this is amplitude shift keying. It's one frequency, but the amplitude is going from nothing, from off to on, and showing as a spike here. And oh, this is interesting, a time domain display. So we can actually see it's pulsing, you know, on, off, on, off. Okay, cool. Let's now go back to the end here and turn off the last sync. And play. Might yell at me. Why is it yelling at me right now? It can be a little temperamental. What's it want from me? Do I have one running? Oh, well, that's annoying. Yeah, so as I said, it can be a little bit temperamental sometimes. Let me see if I can get it to run. Generating flow graph, okay. And execute. You can do it. Oh, demo gods. All right, let me restart it real quick. Sorry about this, guys. All right, we're right back where we were. So let's play this. And here we go. So we see our digital input, the frequency output, and then how we're receiving it. So it's a perfect replication. Very cool. One more example, and then we'll wrap this up. So this is a similar thing, but it's showing a little bit more complicated. And in this case, we're actually using an access code. So in this case, there's a static code coming across, there's ones and zeros coming across, and we're looking for a preamble. It's a certain sets of ones and zeros that always precedes the code that we're looking for, and it tells us that this is the code we're looking for. It's not just random noise. We can use things like this, where we input what our preamble looks like, and it will inject 2. So this is a binary signal we're talking about. But it will inject a 2 into there so that you can identify where the start of your signal is. So let's look at what that looks like. Right, so here's a signal. It's going to come across in a second. There we go. So the input into the demodulator, it's on-off keying as the amplitude. And what comes in is this waveform, and what comes out looks more like a digital signal. Cool, so we're making a translation here. Let's go a little bit further. Let's turn off the input to the demodulator. Look at the clean baseband. All right, so after a few more blocks, we're going to take in what was a little bit of a rough signal, and we're going to clean it up. So this is the rough signal. It's got peaks, it's got overshoots. The timing might not be perfect, and we're going to turn it into a nice, clean digital signal that we're expecting. Cool. Let's disable that guy. Let's turn the time sync on, and let's run it again. So remember, this is after the access code. So what are we going to see? All right, this digital signal came in and it rises and then stays up. But what we want is points in time. We want some ones and zeros. So we want to go from a square wave to a triangle wave. So that's what this is, because we're going to be writing this down into a file as ones and zeros. This peak 2, which obviously makes no sense in a binary format, this is our access code. So this is what that block did to tell us, hey, here's the start of your signal. Everything after this is the data. Cool. So let's turn this guy off. Let's enable the file sync. Let's run this one more time. Let's wait for the signal to come in. There's our signal. Okay, cool. Let's go ahead and open up our there's a GNU radio example in here. Oh, okay, bin. Let's open this up. And so here's our output. We can see most of the time it's off, but every once in a while we have ones and zeros here in a file. And if we look carefully, there should be, here, let me scroll a little bit further down, here, a 2. So we now have a file that we can pipe into like a Python script or whatever we want to start taking this apart. Here's our data, here's ones and zeros, here's our binary of whatever we want to transmit across our data. So this is how you can take GNU radio, and start taking in an arbitrary signal, something straightforward like a on-off keying, and actually start playing around with it in a system. You know, create applications around it, put it into a Python script. Yeah, and that's it. I think that covers the majority of what I wanted to get to. So right now, I know I told you guys I would check the questions, so I will open up the floor and let me look at chat.
All right, thank you, Phil. Do you have access to the chat screen all together? Do you want to run through them one at a time, or do you want me to read them off? And let you
So,
answer?
I mean, if you have anything, I know there might be some just conversation back and forth in here, but if you
No,
saw
they're
any
actually
good.
almost all of its questions.
Oh,
So
perfect.
for the room, you guys have the ability to unmute yourselves. So happy to have you guys type in the chat, ask a question, or you can unmute yourself, ask a question, or you can raise your hand and I will magically unmute you or something. I'm not sure, but go ahead, Phil.
Yeah. Okay, so let me go through some of these questions. Again, I do want to say some of these are pretty technical questions. I am a hobbyist. I probably won't be able to answer a lot of these. These are good questions that I need to read up a little bit more on, but I'll do my best. So the first question is, can you explain how phase would be measured? This, I believe, is done through in-phase and quadrature. This is in the modulation section. I touched just briefly on what I wasn't going to be talking about. In-phase and quadrature is a way of analyzing signatures that helps, for one thing, identify phase of a signal. Let me see. General rule of thumb. Someone brought up the Norquist sampling rate. It's a basic idea in digital signal processing. Again, I am not knowledgeable enough to give a good explanation of that here. So I would recommend they cover it in both the volume that I covered, as well as Michael Osman's video series. Or just go on the Wikipedia page. It's interesting. But that Nyquist sampling rate and the criteria is a very fundamental theory behind this. Yep, look up Nyquist and Shannon sampling theory. Yep, absolutely. What the band and SDR can receive. It depends on what SDR you're talking about. They have different ranges. I would recommend you look at my talk on introduction to SDR. I cover some of the major software-defined radios that are out there and the frequencies that are out there and the capabilities. So I'd point you in that direction. The quick answer is it's typically in the low megahertz to about 2.5, the 2.5, 5 gigahertz range. So like, ham radio up to Wi-Fi is the range you'll typically see. Yep, HackerF goes about to get, yep. So can you pick up radio, cellular, and Wi-Fi? In terms of frequencies, yes. You want to visualize it, go right ahead. Demodulating it is a totally different ball game. When it comes to radio, for example, you're talking about the bandwidth you're covering. You start to get into limitations of the hardware. It's much more difficult to do that with general purpose hardware like a HackRF. You're much better off doing it with specialized hardware. So while you can demodulate Wi-Fi with a HackRF, just get like an alpha. Yeah, right. Don't do it by yourself. Even satellite, yeah, you can do it all. It's all about the implementation. Heavily dependent on bit rate. Antennas, yeah, antennas and all of that are a completely different topic. That I certainly do not have the experience on, but that's all implemented in hardware, right? And that's, how did you learn all the blogs, pointers, and resources? Yes. How did I learn it? The two main resources, and I will go back up here to the in the agenda page to show you guys. Right here. These are the two major resources I use for these talks. Field Expedient SDR. It's a 3-volume series. I believe each one is about $20 on Amazon. The web page that he has with all the demos, completely free. So you can download the demos and play around with them on GNU Radio today for absolutely free. The other resources I'll point you to, Michael Osman, the maker of HackRF, has a really good 11-part SDR series where he goes through in GNU Radio, covers all of the topics we talked about today. And again, free. Check it out, greatscottgadgets.com/SDR. Guys, I will be posting a link to this talk, the links in chat in our Discord and Slack, and I'm sure this talk will be available in not too long on YouTube. So if you have any other questions, I am active on the Discord and the Slack. I think we have SDR channels in both. So with that, I will turn it over. I hope I didn't go over time on that. Nope, perfect timing.
You did not.
Right.
You did great. Thank you, thank you, thank you, Phil.
Absolutely.
We're gonna stop your sharing. If I could get to that freaking control. There we go. All right. Okay, so Tony is up next. Tony, are you ready to rock and roll?
Sure am.
All right. May I ask how long your talk is so I have my thing?
We could do 15 minutes, 30 minutes, or 45 minutes. It's up to you guys.
All right, I'm going to let you roll, and I'm going to let you go ahead and introduce yourself. And do you want questions during your talk, or do you want to save them to the end? Do you want it interactive? Tell me what you need to make you.
Oh, yeah, anybody can jump in and ask a question. I'll put the chat window on my other monitor here so I can keep an eye on it. And also I have some friends here if they want to chime in with an answer. They're more professional. I'm also a hobbyist like Phil, so.
All right, that's fantastic. All right, you go for it. I can see your screen. Thank you.
Awesome. Yeah, so Rod asked me to give a talk on malware information sharing platform. It's a platform that was developed, I think, by NATO and the Luxembourg CERT and the Belgium area sort of EU financing sort of industry. They needed a way to collect information and indicators of compromise for different campaigns and malware and things they were dealing with and different threat actors that were targeting them. So they built a database to do that. So I started using this when I was a threat researcher at a endpoint company to categorize the malware because we would get new malware samples every day. And if we knew that they were phoning home to a known call home or a domain name, or they were using some sort of a registry key or tactic that we could identify and store in a database like this, it would be a great way to kind of help quickly sort of prioritize and route what kind of malware something was, and also, train the malware engines and the signatures involved and stuff like that. So that's really how I got into this platform, kind of built it and stood it up for my team to be able to quickly identify malware. So I'm just going to go over the basics. Obviously, what an indicator is. Most of you probably heard of IP addresses, domain names, and hashes. One-way cryptographic hash of a file. It's like a fingerprint. But there's also things in there like the ABA routing number for a financial scam, or a Bitcoin wallet for a ransomware, or who is registrant for a domain name can sometimes give a clue to a campaign being related to another one. So these are all things that we kind of want to collect, and there's way more than that, but these are just some examples. The other question people might have is, well, why do we collect these things? And I put some examples here. Like I said, in Europe, there was an industry ISAC sharing information that they wanted to say, if these guys are targeting all the banks, we want to know about them and share that information. So we kind of have more of an immune system around our banking here in Europe or something like that. Tracking a malware campaign as a researcher is the use I used for it. But we've also seen people automating and validating and enriching their SIM content. They might have written signatures or gotten vendor information or logs in, and they can compare it to known bad activity and maybe enrich the data by giving you context around, yes, the signature fired and it's going to a known, bad address or something like that. Or just maybe if the SIM content's not working and you see something, you can investigate and find out and fix it. So it gives you some sort of operational validation that things are working the way you intend. It also gives you a way to communicate with vendors without giving them too much information. So we've seen a lot of people say, hey, you didn't catch this, to their vendor. They provide some information, some domain names, some IP addresses, then they're able to improve the products, and everyone benefits from that as well. And another thing is historical searching and review of data. Once you do have a identified threat actor, you can go back into your data and figure out maybe at the dwell time, which is how long have they been operating in my network. And that way how much damage or how many footholds they might have established in your network. And again, automation is the last thing. It's a big piece of where we're going in this next decade. We all need to, learn our Python and our automation tools to kind of make the easy stuff happen a little faster. So having data around that makes our scripting more intelligent. So use cases for MISP, we've kind of touched on that in the last slide too. But here's some more use cases. But for me, it was about collaborating with the team, number 5. searching and seeing that this malware is doing this, that this other malware did, kind of tells you right away that it's related, you know, unless it's just a commonly compromised public host that is being passed around by different threat groups, but you know, that can happen as well. But it's just it's a quick way to identify things and collaborate with your team when you have a lot of data to process. And then the first thing too is this product has a it's not a product, it's open source, but this platform has a way to search from, you know, your SIM or from Slack or Discord. So one of the things we did on our Discord was we made just like a quick way to search, where we could search for a hash for instance, and get an example back, or you could search for a domain name and get several examples back, or you know, even a threat actor name, and like Lazarus, which is tied to a specific nation state actor. So it's just kind of a way for your analysts to be able to quickly query it without jumping and logging in and doing a bunch of work. Just, you know, having those things available. So the main thing is getting data into the platform. So some of the sources for data, we have vendor blogs like, you know, Palo Alto, Cisco, Talos. Then you have the online threat exchanges from IBM, Alien Vault, Threat Connect. There's so many sources, but there's also feeds inside of this platform as well. So you can turn on the feed from the Luxembourg Circle. You can turn on all sorts of feeds from the Swiss cert, abuse.ch. You can bring in even a Tor node list or something like that, so you could be aware of that type of activity if it's in your threat profile to do that type of work. And so this is kind of just some of the sources for the data, but really the most important sources are going to come from your reverse engineers on your company staff or something like that, to find, you know, the threat actors that are specifically targeting you and having a place to put that data. So that's going to be kind of the most important data. So here's an example too of once we get a bunch of data in, some of the correlation we can see from the data. So we see here a bunch of hashes and domain names and how they're related. So here we have a Palo Alto blog entry called the Gorgon Group, a nation state actor. And we can see here that they had the same IP address that was related to another one of their blog posts called Subat. And we can also see that a Microsoft Hawkeye keylogger article shared a lot of indicators with it as well. So we can start to see, even Cisco Talos had chimed in that there was a threat roundup in August that mentioned one of the hashes involved. So it kind of gives you a unique view of what different threat actors are being reported and how, and what the different names are, which has kind of been a bit of an issue in the industry, because you have FireEye might call it APT and then a number, and then you have CrowdStrike might call it Bear, Fancy Bear, or something like that. And you have Microsoft might call it Strontium, and then, you know, somebody else might call it Spider or something like that. So there's kind of a naming problem as well. So this is something that we can talk about how to address that if that's of interest to people as well. So just kind of having not to depend on your memory for all of these millions of indicators for how they relate to each other is a huge lift for SOC analysts and threat intelligence folks that are doing work on this type of stuff. So let's talk about also data enrichments, right? So we've taken the effort to put all this data into a database and collect it. What do we want to do with the data? So one of the things we can do is we can enrich the data by querying against, you know, different services as well. Not only can we get indicators from Alien Vault, but if maybe they don't come from there, we can check to see if they're in Alien Vault and get more indicators. Or another cool one is the Risk IQ passive total one. If you have an IP address from a vendor that's bad and you don't know why it's bad, well, you might get a list of 30 domain names that are parked on that IP address and then be able to figure out more and go a little deeper with your investigation. So these little things kind of help. And even with Shodan, where it's more like, well, what services is this IP address hosting? You can go and look and see that maybe it's hosting a webcam security camera and it got compromised or something along those lines. You never know what you're going to run into, but having these extra tools to query and bring in data with is really helpful. And lastly, we have here is the MISP is part of an ecosystem called the Hive and the Cortex ecosystem. And then Maltego is a visualization tool that takes the relationships a bit further than what's built into the tool. So you can actually have a security incident response platform that integrates with this. You can have malware samples actually available and uploaded through MISP and through these platforms as well. So you have access to them if you want to reverse engineer them. So there's all sorts of stuff that you can bolt onto this. It's really just a starting point. And for me, it was just about collecting the data and taking a look to see if it was worth collecting. But also another thing I think is very important is the data when it's published could change down the road. So having the data as it was published to me is very important. As stories change, as narratives change, as nation states get involved in cyber and cyber war considerations, having a point of reference is really interesting to me. So that's another reason. So any questions about the platform so far or anything like that before we jump into a working platform to show you what it does? All right. So again, MISP is available at GitHub. The Hive is available here at the project and hiveproject.org and mispproject.org. There's tons of information there about the platform. So this is my personal server that I've set up, and I've pumped data into about 5 years worth, and the crowd's asking for the demo. So so this is basically the event list when you log in. So some of the stuff that I think is really cool is you can see here how many attributes or indicators are in each event, and you can see how many different things it correlates with as well. So you can see that it's related to 12 other things that are in the system, and that's pretty cool for learning about stuff. So let's go take a look at, actually, let's start with Emotet. So this is a very common mass mailer that we see week after week. It's pretty relentless. It tends to bundle with TrickBot. So what we can do here is we can actually tag this and say that it's a mass mailer, or maybe TrickBot. You know, it's related to TrickBot or something like that. So there's a tagging functionality here, but there's also a Galaxy functionality where we can say, you know, this is Emotet, and it'll tell you that it's related to the Geodo family as well. So it's already able to give you context about some of the malware families and the types of stuff they're looking for. And from there, you can actually look, I think, one of these guys tells you a lot of information. Yeah, so this is taking you into the Galaxy's piece of the platform. We can see here a bunch of article references about this malware if you wanted to learn more about it. So having that sort of Galaxy that ties together all the threat actors, all the names, all the terminology and lingo really helps get up to speed on some of these things very quickly. So down here, how we enter these indicators is you can click here and use a free text import tool and just paste a ton of IOCs from maybe Pastebin or from a vendor blog or something like that. And you hit submit, and then you can add a comment to each one. So I can see here that this IP address was added, and it came from this Emotet working group, Cryptolimus, his Twitter account or their Twitter account. And so we have a frame of reference for when, you know, where it came from and when it was added to the system. And you can also see the events it's related to here in red. So when we do want to take a look at all the different things that it's related to, for instance, here's that TrickBot relationship I mentioned. You can just click here on correlation graph and you'll get like a bunch of relationships here. So we can see in July of, you know, this year of probably 2018 here. Let me see here. Yeah. So there was a Dridex campaign that they were delivering malware for Dridex as well with Emotet. And you can see in November, these IPs were used. You can see over time that it's using some of the same infrastructure from week to week, month to month, year to year. And see that even though they're not changing much, they're still getting away with and delivering different malware. So what we've termed this is kind of as access as a service, or yeah, you know, compromise as a service, where they're bringing in whatever Dridex or TrickBot or whoever wants to pay them to get access, because they're very efficient at delivering those payloads, even with the same IP addresses month over month. So yeah, any questions about this visualization or what we can do with this data? Does this seem interesting to anybody at all? Would this help you in your security operations?
Yeah, everything looks good. The more I'm seeing the presentation, I'm wondering whether there's an integration with Security Onion where you can actually take those PCAPs. Or is this more of a replacement to something like that, or to that type of platform?
That's a good question. I haven't actually used that Security Onion. There might be an integration here where you can go in and add an API key.
Okay, cool.
Yeah, and if Security Onion has an API, that's a great way to do that. And also, Tom Hacks is mentioning the export functionality too. So any data that's in here can be exported to Snort or Bro or Suricata. You can do this on an event level, or you can do this on the whole server level. So that way you're able to, even Yara as well, store data in here that can be used by other systems and export it. So since this is an open source project, again, I'm not familiar with Security Onion, but maybe you could make an export sort of function here to bring this data in to them, and also automate using their API, all sorts of stuff that you can send and receive through the API with other products. So like I said in the presentation, there's a ton of products they integrate with. I haven't even gotten through them, but I think there's over 150 entries in the import-export sort of area alone of this platform. Yeah, thanks. As far as the Discord bot goes, I don't have Discord bot on this machine, but we just built it to query the search all handler in here. And what it allows, allows your analysts to do is they're seeing a weird domain name they've never seen before, or they're seeing a weird, IP address. They can search really quickly and get a result back, a hash or something like that. They can also do that against VirusTotal or any other service as well. So we're going to start to see more Slack bot functions and Discord bot functions like that as we go, where we'll be able to query a bunch of services at once. And I think MISP is a pretty cool one to add to that, especially in a corporate setting. If you don't already have some internal tools that are well integrated, it's a great thing that can just drop in and integrate pretty easily. All right. So yeah, are there any threat actors or campaigns you guys would be interested in searching for in here that that would be interesting to anybody? Like the Gorgon group was one too, as we can do. Can we take 2 or more MISP deployments and connect them to shared data? Yes, there's actually a sync action here where you can have servers that share data directly, and you can also set the publishing level and the distribution level of each article. Does it do JA3 hashing? I have not heard of that. Let's check. So when we add an indicator down here, we can just add a single indicator. I think it'll give us a list. And there's MD5, SHA-1, SHA-256, JA3 fingerprint MD5. Is that what you're looking for, Cisco? Ah, right. So we do have that in here. There's also the other one that I can't think of right now, like SSD or something like that is in here as well. Manage instance or yep. Yeah, so you can have like an ISAC that has everybody's connected below it, and that way you don't send your data up to the ISAC until you publish it, and they can send all their data that they publish to you guys. So you can have an ecosystem of these servers where you're sharing the data you want to share and publishing what you want to share. And the way the servers go is there's like these communities here. Let's see. Yeah, so you can have locally published, you can have it published to your community, or you can have it published globally. So there's multiple levels, is what I'm trying to say, for where you can have data go and filter up. And you can have this stuff here, published globally, but if you're not connected to anybody, it won't go anywhere. It just stays on the system. Cool, good questions, guys. So the other one I wanted to talk about was the Gorgon group, the one that I showed you where we had a Palo Alto release, but that it was also mentioning a Hawkeye keylogger, and it was also mentioning Subat, and is mentioning in Cisco Talos as well. So we can see here when I entered this data, I saw immediately those relationships pop up here, and we're able to look at that and see here that it's related to Hawkeye keylogger. And when I read the Gorgon group blog publication, I didn't see him mention that at all, and I thought that was kind of weird that they left that out. So if you're even a researcher at one of these kind of elite threat intelligence units, you should dump your indicators into one of these things and make sure you're not missing a connection here. Is kind of what we see. And so what we ended up doing was we would tweet at the researchers from Unit 42 at Palo Alto and say, hey, there's a connection here with this article, and send them the link to this Microsoft Hawkeye keylogger article here that James in the box tweeted out. And I think there was an actual Microsoft, article here. So yeah, it was kind of interesting to be able to participate in that way with the researchers and show them those extra relationships. So we take a JA3 hash collected and query it and get the OS browser that made the requests, even if it's trying to obfuscate. Okay.
Yeah. So for example, when you make a SSL TLS connection to a server, you can get that fingerprint before it encrypts the connection. Okay. And because you're hashing it with JA3, right? If you're collecting those fingerprints, and we've this is an open source project as well.
You make like a rainbow table for it?
Well, they already have in their database. So if, for example, somebody's hitting you with Metasploit, but they're saying, no, I'm Firefox, because we already have the fingerprint for Metasploit, we already know, yeah, no, you're lying to us. This is an actual attack.
That's pretty useful. Yeah, I hadn't run into that yet. I like that. All right. So if anybody has any questions, we can keep going and digging into the platform, but I really just wanted to share it with you guys and let you know on Discord, if you want to reach out on the Threat Intel channel, my name on there is Service Pack, SPP RIDE. And so, or MIA, I think at the end, Spride MIA. If you guys want access to read only, to be able to query this, or if you want to contribute and want to talk to me about this, feel free to reach out. We can always use more folks adding data to this. Like I said, a lot of it does come in automated, but I do still add manually a lot of blogs and stuff like that, just to make sure we have a good coverage of data. So we can also make a separate organization within my server for Hackmiami, so you guys can have your own working group and be able to take all the data that's in here, plus whatever you guys want to publish and share and connect with. So that's an option for anybody who's super interested in that. Let me know and I'll be happy to set up an account for you. So that's about all I have for the day, if there's no questions. All right.
No questions, anyone? All right. Well, Tony, really, really appreciate that. That was a lot of good information. Thank you very much. I know people usually ask if slide decks are going to be available. I know we did a recording of the meeting. We'll put that up in the YouTube channel as soon as we get that. But Tony and Phil, will you be giving me your slide decks?
Well, I've already made them available on Slack and Discord. So if you go to the SDR/Wi-Fi channel in Discord or the radio frequencies channel in Slack, you'll find the PowerPoint as well as all the additional resources I mentioned.
Yeah, I can share mine with Rod and he can send it over to you. I don't have your email personally, but I'll send it to Rod.
Okay, no problem.
Okay.
All right, well, thank you guys very much. Does anybody have anything they want to offer up? Any kind of quick discussions or anything like that? Announcements of any kind?
I will say I am working on a badge for DEF CON next year.
Really?
So, yeah, I already bought an oscilloscope for it, so I'm invested. But if anyone is interested, seriously interested in developing a Hackmiami badge, let me know. Yeah, no, absolutely. It's going to be a serious badge. So
pick me.
Yeah.
Oh wait,
So
I forgot the jumping up and down part.
I'm active on Slack and Discord, so just get in touch with me. I'm actually posting some pretty regular updates on the hardware channel on Discord if you guys wanna get in touch. So I'll just put it out there.
All right, thanks guys. Have a great weekend and see you in a couple weeks.
Sounds good. Thanks, Daniel.
Bye guys.
Thank you.